I take a circle with center O, and there is a point P lying outside the circle. You can see it blinking right here, right? The point P. Now from this point P, I will draw a line that meets the circle in exactly one point. Okay, and let that point be equal to A. So this line PA, it is called as the tangent to the circle. Okay, so tangent is any line segment which starts from outside the circle and meets the circle in exactly one point, one unique point. Okay, now if I draw the radius OA, guys, in this case, okay, so I will observe that OA is perpendicular to AP. Okay, so this is called as the tangent perpendicularity theorem. It says that a tangent at any point on the circle is perpendicular to the radius through that point. मतलब अगर आपने एक external point से अगर एक tangent draw किया है on the circle, okay, at that point if you drop the radius will be perpendicular. It is called as the tangent perpendicularity theorem. The proof is right now out of the scope, but if you want it, just request it, we can make it in the bonus videos. So we go on further. Now what I will do next is from this point P, I will drop one more tangent here, okay, and one more perpendicular over here, okay, and I'll let's say call it some other point as B. Okay, now guys, I'll join the line OP here in this case, okay, and you will be able to observe two triangles, the triangles POA and triangle POB. Now guys, in these two triangles, you can observe that angle OBP and OAP both are 90 degrees. So both are actually right angles, right? OB is equal to OA, the radii of the same circle, and OP is the common side, right? That means the two triangles are congruent. They are congruent by the hypotenuse side test. Okay, as a consequence, I can say that PB ka length jo bhi hoga will be equal to PA ka length, right guys? Okay, so that means the length of two tangent segments from an external point to the circle are equal. Tangents. Okay, so find the perimeter of triangle PAB if PD is equal to 12 centimeters. You can pause the video and try it out. It's a very good question, and then we're going to discuss. Okay, guys. So we know that PD will be equal to PC. Okay, from this point P, I'm drawing two tangents. एक ये PD है, दूसरा ये PC है, right? So both of these lines will be equal. Why? Tangent segments from external point to circle are equal. Same way, guys. A से D, अगर मैंने AD देखा और AE देखा, A से I am forming two tangents, right? एक ये AD है और एक ये AE है, right? Isn't it? So A will be equal to AD, right? Same B will be equal to BC in this case. From this point B, okay, I'm drawing two tangents, BC and BE, right? Both should be equal. Why? From the external point P, I'm drawing tangents, right? In तीनों के लिए same reason है, tangents from external point to circle are equal. Okay. Now remember this, guys. As we go on further, writing the perimeter of triangle AAB, guys. Now PAB now, guys. PA plus AB plus PB ये होगा अपना perimeter. Okay. Now AB को हम split करते हैं, guys. कैसे split करेंगे हम लोग AB को? AB को हम split करेंगे as AE and BE in this case, right? And now just now we said AE is equal to AD, so हम लोग AE को replace कर रहे हैं AD से, and BE we took as equal to BC, right? So BE को हम replace कर रहे हैं BC से. Okay. Now guys, if you observe carefully, what is PA plus AD? PA plus AD is nothing but PD, this tangent, right? Same way, BC plus PB, BC plus PB is nothing but PC, right? This entire tangent. Okay, so replace this entire thing, okay, PA plus AD as PD, and you replace PB plus BC by PC. ये PC होगा. Okay, but also we studied that PD is equal to PC, right, guys? PD is equal to PC अगर same होगा, okay, you can replace this with twice of PD or twice of PC, whatever you like. Or you can just put on the values. The values will be 12 plus 12 equals to 24. That's the required answer. So it's not a very calculative. It's more of a conceptual question, right? All right, guys. So we go on to the next part. Let's solve this one. For two circles having radii capital R and small r with the distance between the two centers d units, find the length of the direct common tangent. So you can observe here are two circles. एक का center A है, दूसरे का center C है, and there is a direct common tangent OD between these two. Right, that's a direct common tangent OD in this case, and iska radius is given as AO, jiska length capital R hai. Iska radius is given as small r, which is CD. Okay, I'll make a small construction, and that is I'll drop a perpendicular CB, right, on the line AO in this case, guys. Now observe carefully, guys. Since CB is a perpendicular, I'm drawing on line OA. By tangent perpendicularity theorem, ये angle BOD 90 degrees होगा. Okay, and similarly, angle ODC also will be 90 degrees. And I'm dropping a perpendicular, so angle OBC also is 90 degrees, right? So more or less you can say that OBCD will be a rectangle. Okay, this figure I have highlighted here, it's a rectangle. Okay, तो अगर ये side R हो गया, OB भी कितना हो जाएगा? Small r. And similarly, if you observe carefully, guys, OA पूरा capital R के बराबर है, right? उसमें से you remove OB, so you will get BA as capital R minus small r, right? So now I'll take triangle ABC separately and apply Pythagoras theorem. I'll be getting the equation as AC square, the hypotenuse, is AB square plus BC square, right? Pythagoras theorem I have applied. Okay, now AC is given as small d. Okay, AB is given as capital R minus small r. और BC जो अपना डायरेक्ट कॉमन टेंजेंट जिसका हमको लेंथ फाइंड करना है, आई एम अज्यूमिंग इट्स वैल्यू इज कैपिटल L. So applying the Pythagoras theorem, AC square, which is D square, is equal to AB square, which is capital R minus small r the whole square, plus BC square is equal to capital L square, right? So L square is equal to D square minus R the whole square. That gives us L as square root of D square minus R the whole square. So you can also remember this as a standard formula right now, guys. Okay, for the length of the direct common tangent, it will be square root of D square minus R the whole square. Okay, where D is the distance between the two centers and R minus R is basically the different radii. R is the radii for the bigger circle, capital R. For the smaller circle, the radius is small r. Okay, so the length of the direct common tangent is square root of D square minus R the whole square. Okay, let's go on to the next part. For two circles having radii capital R and small r, with distance between the centers d units, find the length of the transverse common tangent. Okay, so as you can see, the transverse common tangent here is OD जिसका मेरे को length find करना है. So what I will do is, guys, I will extend the line AO and I will extend the line CB here in this case. You can see it, right? So they meet at a point, let's say B. Okay. Now, as I told you previously also, there is a rectangle being formed, BODC in this case, just like the previous case. BODC will be a rectangle here, right? है ना? तो अगर ये small r है, BO also is small r, right? So if you observe carefully, guys, यहाँ पे I have a right angle being formed, right? The right angle triangle is ABC. Okay, इसमें से guys अब AB क्या हो जाएगा? See, AO is capital R and OB is small r. What is AB equal to? Capital R plus small r, right? And the distance of the two centers is D units, right? So what we'll do is we'll again apply Pythagoras theorem. Okay, for AC square equals to AB square plus BC square. AC का वैल्यू D है, AB का वैल्यू R plus R है, तो L square क्या होगा? L square होगा D square minus R plus R the whole square, or L is equal to square root of D square minus R plus R the whole square. So now you can remember this as a standard or a standard formula for finding out the length of the transverse common tangent.